So now moving to the our third topic of discussion, which is basically argument. Okay, argument of a complex number. So what is the argument of a complex number? Now again, I am trying to draw the complex plane. Okay, complex plane. See, this is our again same thing, real axis, and this is imaginary axis. Okay, imaginary axis. This is our origin. So here we have discussed about the modulus. Let's consider z is equals to a plus iota b is any general complex number if I take a comma b as positive real number. So I will plot here a comma b. So from origin, okay, from the origin to that complex number, my distance is what? Means it will represent what? It will represent modulus. Okay, modulus of z. Simple modulus of z it will represent. So if I want to reach on this point a comma b, so first of all we will measure the distance between the origin to that plotted complex number point, and then we have to mark the angle it is making from the real axis. These two things if I tell you, then you can easily go to that plotted point a comma b. Yes. So what is this angle theta? The angle made from the positive real axis to the line segment joining the origin to that plotted complex number, or we can say to that complex point, is called our argument. Okay, this theta is basically known as argument of this complex number, which is basically z is equals to a plus iota b. Okay, so now the important thing come that this argument can be infinite. Okay, means see, if I again try to plot this Argand plane. Okay, so this is our real axis and this is our imaginary axis. Okay, and this is the origin, and this is our plotted or required complex number a comma b. Okay, and this is our modulus. Okay, and this is our modulus, and this is our modulus, or we can say length. Okay, so one can, so it is not necessary that we will measure this angle theta in this direction. Means one can measure this theta like this also. See, one can rotate 2 pi and then, so one can rotate whole 2 pi plus theta and say that I have measured this particular angle. Okay, one can also say that I will not measure like 2 pi plus theta. I will make the round one time more. It means what? Here it is to 2 pi plus theta. No, I will make one rotation more. Means like this. It is 4 pi plus theta. No, I will not make 4 pi plus theta. I will make one round again. Means one rotation, full rotation again. So means like this. It is 6 pi plus theta. No, one rotation again means it is 8 pi plus theta. Means it is increasing. How many times? It is increasing in the multiple of 2n pi plus theta. So where n is what? N is an integer. And as we all know that it is measuring this angle theta only, no? It means according in the terms of measurement, theta is what? Equal to 2 pi plus theta. It is also equal to 4 pi plus theta. It is also equal to 6 pi plus theta. It is also equals to 8 pi plus theta, and so on, dot 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 dot. So it is a multiple of 2 pi. It means what? It is all are what? It is all are arguments. Okay, basically all are arguments. So arguments can be infinite. Okay, arguments can be infinite. So if we are measuring theta in the anti-clockwise direction, okay, basically it is a convention that we always measure theta in the anti-clockwise direction and we consider theta as positive, and if we measure theta in the clockwise direction we will take theta as negative. Okay, we are measuring from in the anti-clockwise direction, that's why we are taking plus theta, and if we measure in the clockwise manner we will take minus theta. Okay, so argument can be infinite, but when I will remove this 2 and pi, this theta will lie in the range minus pi to pi, which is basically the principal argument, which is basically principal argument. Okay, principal argument. Okay, so if theta lies between minus pi to pi, it is called principal argument, and it is also called amplitude. Okay, it is also called amplitude of complex number, means Cn. I am denoting as Cn, amplitude of complex number. It means here we can also write like this, amplitude of Z or ARG of Z, same thing. Okay, it means we can say that, so we can say that every amplitude is an argument, but not every argument is an amplitude, because amplitude is unique. So if my theta will lie between minus pi to pi, then it is called the principal argument, or we can say the amplitude of that complex number. Okay, amplitude can never be infinite. Okay, amplitude will be unique only, and unique when our theta will lie between minus pi to pi. Okay, means not general argument. Okay, it is called what? General argument, not general argument, but it should be in the range from minus pi to pi, or basically we can say principal argument. Principal argument always lies between minus pi to pi. Okay, so here we will be talking about 4 cases to how to find out the argument. We have learned that what is argument and how we will now find out the argument. See, first let's draw the 4 Argand plane, because we will be discussing about 4 cases. Okay, one here, this Argand plane, this Argand plane, this Argand. See, these are the 4 Argand planes consisting of real axis and imaginary axis. So first case, I am considering that if let my complex number, I have plotted my point here a comma b, and this is origin. Okay, so my complex number lies on, so let my complex number lies on first quadrant. Okay, lies in the first quadrant. So if it lies in the first quadrant, then what? Then from origin to here, it from origin to that plotted point is what? So the plotted point so that plotted point, so from origin to that plotted point a comma b, it is what? So from origin to A comma B, it is called what? Modulus, that we have already studied earlier. It is called what? Modulus of Z. If I want my argument theta, so this is our theta, this is our real axis. Okay, this is our real axis, and this is our imaginary axis. Imaginary axis. So if I want to find out our theta, so how we will find out our theta, means how we will find out our argument. See, it is very simple. Let's suppose if I drop altitude from A comma B to the real axis, so it is what? A comma B means the horizontal distance. The horizontal distance is what? Basically this horizontal distance is A. Okay, A units in the real axis and B units we have gone along the imaginary axis. Simple, B units. So if I ask you, see, we can see it is an right angle triangle. If I ask you that what is the our tan theta, so we will say tan theta is what? P by A. It means what? Theta is equals to tan inverse P upon A. So this is our argument. Theta is equals to tan inverse P by A is our argument. So here I am writing theta is equals to what? Tan inverse P by A is our argument here. When my A comma B lies in the first quadrant. If my A comma B point lies in the second quadrant, so what it will happen? See, let's suppose this is our real axis only, and this is imaginary axis. This is imaginary axis. This is our origin. If my point lies in the second quadrant, if my point will lie in the second quadrant, it means it will have what? Minus A comma B. Okay, minus A comma B. The real part will be negative and imaginary part will be positive only, minus A comma B. Okay, means here complex number is like this, minus A plus iota B. This will behave as a point minus A comma B in the second quadrant, simply like in 2D plane or Cartesian plane just we are doing. And this distance from the origin to that point is called modulus. Okay, this is called our modulus Z. This is what? This is modulus of Z. Now similarly in the very similar manner, if I drop the altitude from minus A comma B to this real axis, what we will get? And see, this is our theta. And let this right angle triangle, this, and let's suppose that this angle is my alpha angle. Okay, this is our alpha. And now if I ask you what is the theta, and if I ask you what is theta is this angle. You can see theta is this angle. See, this is our angle theta, which is making an angle the positive real axis to the line segment joining origin to the point minus A comma B. This is theta. And let's suppose this is any angle alpha, which is making an angle anti-clockwise sense from the real axis to that line segment joining origin to the point minus A comma B. Yes, it is very clear. So in the very similar manner, I can write it will go A units in the left side. Okay, A units on the real axis left side, A units, and B units upwards, B units along imaginary axis. See, B units here b units. This is what? Going upwards, b units. Okay. Now this is what? Now here, if I ask you tan alpha, okay, tan alpha is what? Tan alpha is b by a, or we can give the modulus also, because it is length, the length of the triangle cannot be negative, and this is to the this is the coordinate representation point. It will be minus a comma b, and if we are talking about units, distance, so it will be perfectly positive only. So if we want, then we can, so if we want, we can give the modulus also and write the respective sign, b upon minus a, then modulus, same thing. So from here, what we can conclude? We can conclude that alpha is what? Tan inverse under modulus b upon minus a. Means same thing, no? B upon minus a modulus, or we can write b upon a, same thing. Okay. So alpha we got is tan inverse under modulus b upon minus a. So what is our theta? Theta is what? Theta is, see, from here to here, it is whole pi only, no? From this real axis, from the positive real axis to here, to this negative real axis, this whole angle is what? Pi. So pi minus, and alpha is in anti-clockwise direction, and anti-clockwise, and pi is pi minus. So here see, it is alpha. Alpha is going from here to here. It means what? In which direction it is going? It is going in the clockwise direction. In clockwise direction, we have set our standard convention that if we go in the clockwise, then we will measure minus. So pi minus alpha. Alpha value is what? Tan inverse under modulus b upon minus. So this is our theta, or we can say this is our argument if my point lies in the second quadrant. Okay, now moving to our third case. Okay, third case is also similar. So this is our what? This is our real axis. This is our real axis. This is our imaginary axis. This is our imaginary axis. So if my point lies, okay, if my point lies here, means minus a comma minus b, then again whole similar manner we have to do. Okay, very easy. See, this is our modulus, mod z. Okay, now again you just drop the altitude from minus a, from minus a minus b to the negative side of the real axis. Okay, see, and now it is making some angle alpha. Angle alpha it is making, and it is what? It is a. It is a, and here it is b. Okay, a units and here b units. Now here similarly, if I ask you what is tan alpha, so what you will tell? Tan alpha is equals to what? Under mod minus b upon minus a. Okay, it means what? Alpha is equals to tan inverse under mod minus b upon minus a. So if I ask you theta, now theta will be what? Theta will be minus pi minus alpha, because we are moving in the clockwise direction now. So we have to take minus pi. From upwards, from here to here it is pi, and from downwards, if we are moving in the direction of clockwise, in the direction of clock, then you have to take minus only, so minus pi. Then theta will be what? Minus pi minus alpha. So my argument will be what? Minus pi minus of tan inverse under mod minus b upon minus a. Okay. So what is our fourth case? Fourth case is simple. See, fourth case is like this. This is our real axis. This is our real axis. This is our imaginary axis. Okay. This is our imaginary axis. This is our 0 plus 0 iota. Okay. And if my point lies here in the fourth quadrant, it means what? Fourth quadrant means what? A comma minus B. Okay. A comma minus B. See here, the point is lying A comma minus B. Okay. Okay, A comma minus B. And this is what? This is again simple, same thing. Modulus is modulus. Okay. And if I try to and then you drop the perpendicular from A comma minus B to the positive side of real axis. Simple. Same thing we are doing. Now this is what? This is A. This is what? This is B units. Okay. A units and B units. Simple. Okay. A units. This is what? B units. Okay. And what? And this is what? This is the alpha only, no? So tan alpha is what? Tan alpha is again minus B upon A. So alpha will be what? Alpha will be minus of tan inverse under modulus minus B upon A. Why minus? Because alpha is in what? Clockwise direction. And clockwise direction we always measure in the negative sign. Okay. That's why minus. Okay. Because it is moving in what? In the clockwise direction. No. That's why. This is only our angle theta. Alpha here. Alpha is theta only. Means here it is argument only. So this was the whole thing, whole concept about the argument of a complex number.